In this video, we are going to learn about how to write formulas for ionic compounds. Now let's start talking about what is an ionic compound. An ionic compound is formed of two things: cations, which are positively charged ions, and anions, which are negatively charged ions. So looking at this example right here, this is, by the way, our ionic compound, sodium chloride. And sodium chloride is also known as our table salt. And looking right here at sodium chloride, you see that the cations and anions, okay, which are positively and negatively charged, arranged in a very specific way. Now we have here our cation, which is the sodium ion, positively charged, and our chloride anion, which is negatively charged. Now, when they come together in this very neat and very arranged manner, they form ionic bonding, which is a type of electrostatic interaction. And by the way, we will be talking more in depth about ionic bonding later in the semester. Now, talking about cations, what leads to the formation of cation? So if an atom loses, and this atom is usually a metal, okay, so usually a metal, this ion, as a result of electron loss, becomes positively charged and called a cation. And sometimes you can have also a group of atoms that are bonded together, and they can also form a cation. So examples of an atom that tends to lose electrons, which we referred to before as metals, are sodium ion, potassium ion, calcium ion, aluminum, okay? Or a polyatomic ion, as I mentioned before, is NH4 plus or ammonium. Now in cations, note that because an electron is lost, as in here, sodium lost an electron from its outer shell, you have the number of protons now are greater than the number of electrons. As far as anions go, you can think of the same concept as cations, but instead of losing electrons, they tend to gain electrons, and as a result of that extra electron, they become negatively charged and called an anion. And these can be an atom, so like fluoride, bromide, oxide, nitride. We will learn, by the way, the naming. Or you can have also polyatomic anions. So these are polyatomic anions, such as sulfate or perchlorate. And we will also learn how to name our ions. Now, in anions, which is opposite of the cations, the number of electrons are going to be greater than the protons. So if you look at the chlorine atom right here in its outer shell, if it gains an electrons, you have one extra electrons, and that what results in the negative charge. You are also expected to know what kind of charge do each atom acquire based on its position in the periodic table. So, for example, we can learn trends as far as the positions in the periodic table. So, for example, we have here metals are to the very far left of the periodic table, and group 1 metals minus the hydrogen, okay? And think about it. If it's in group 1 and it's a metal, so it tends to lose 1 electron. So you have a plus charge. Plus charge here indicate that it is a plus 1 charge or 1 plus charge. Metals of group 2 here because they're in group 2. So think about it, they have the tendency of losing 2 electrons. So something like magnesium ion, calcium, strontium. And the transition metal ions right here, you can see that some metals like chromium, like iron, like cobalt, they tend to have like ions that can form multiple charges. Now we will also learn about this later when we are naming ionic compounds. And here we have here something like aluminum. Aluminum is a metal in group 13. It tends to lose 3 electrons, so 13 or 3a, so 3 electrons. Now to the very far right of the periodic table, we have our nonmetals. So our nonmetals tend to gain electrons and form anions. And in this case, you have something like nitrogen and phosphorus both tend to lose 3 electrons, tend to gain 3 electrons and become nitride N3 minus and P3 minus. Group 16 right here, consisting of oxygen, sulfur, selenium, tellurium, they tend to gain 2 electrons and form a 2 minus charge. As far as group 17, our halogens, they tend only to gain 1 electron. So to summarize, we have to the very far left and to the middle our metals, and these tend to lose electrons and form cations. To the very far right, we have our anions that tend to that tend to gain electrons and form anions. Now, when a metal loses, in this case, back to the example we were discussing at the beginning, when a metal atom like sodium tend to lose an electron, that electron is transferred to the nonmetal, okay? And in this case, you have a cation and anion forming to give me this very neat and very ordered crystal structure arrangement. Now let's see how we can read and write the formulas for ionic compounds. So I will take this example of CaCl2. So when the formula of ionic compound written, we start first from left to right by writing the metals. So we have here calcium. Calcium is in group 2, far left, and this is the metal. And then we have the second part of the formula is the nonmetal, which is our chlorine or chloride ion, nonmetal. Another thing we have to consider is our ionic compounds are, although they consist of a positive and a negatively charged part, the compound as a whole is neutral, means that its overall charge is 0. So that means that when you're writing the formula, the cation and anion in the formula unit will have to be in proportion. So again, let's look. So for going back to the example of calcium chloride. So calcium chloride, you know here that there is 1 calcium cation, okay, and 2 of the chloride anions. So in this case, because you have here a 2 plus charge on the calcium cation, so you have to include 2 of the chloride, which has a 1 minus charge anion to neutralize the 2 plus, forming a neutral compound. I hope that makes sense. Now let's see how we can write formulas for ionic compounds, and then we'll be working on examples. Now, first of all, to write the formula of an ionic compound, and in this example, I'm going to use the compound, I'm going to use magnesium and nitrogen. So first of all, we will start by writing the symbol for the metal cation. So in this case, we have here magnesium 2 plus. Okay, sorry. We will start by writing the symbol for the metal cation and then its charge. So you have here magnesium 2 plus, all right, and then the nonmetal. So the nonmetal is the nitrogen, and nitrogen tends very, again, far right, tends to gain, and it is a 3 minus, okay? Now, we will use a special method called the crisscross method. So please pay attention. In the crisscross method, what happens is the value of the charge, so the value of the charge for magnesium 2 plus is, for magnesium is 2 plus, and for the nitrogen is 3 minus. So the absolute value of the charge becomes the subscript of the opposite ion. So if you look right here, the 2 plus right here becomes the subscript of the nitrogen, and here the 3 minus, or the 3, becomes the subscript of magnesium. So again, let me demonstrate for you. So it becomes the subscript. The 2 becomes a subscript for the nitrogen, and the 3 becomes the subscript for nitrogen. And then this results in Mg3N2. So what does this mean? This means that for every or for the formula unit of Mg3N2, I have 3 Mg2 plus ions and 2 N3 minus ions. And this is what results in charge neutrality. Now, sometimes you will have to reduce to the lowest common denominator. Of course, this is to the lowest common denominator. You don't need to do anything, but I can give you an example. Like, for example, if you have a compound formed from calcium and oxygen, okay, ion, calcium ion and an oxygen ion. Now note, if we're using the crisscross method right here, that we will, and if we just have the charge as the subscript, you will end up with Ca2O2. And in this case, we will have to divide by 2 to reduce to the lowest common denominator, and we'll get CaO. Okay, and then make sure that you have the same number of positive charges and negative charges. So again, in calcium oxide, I have a 2 plus and a 2 minus. So 2 plus 2 minus equals 0, and that means it is a neutral compound. Now let's check your understanding and see if we can together write the formulas for these combinations A through C. So starting with magnesium and sulfur. So magnesium is a metal in group 2. Metals tend to lose electrons, 2 plus. And then sulfur ion is nonmetal, tends to gain 2 electrons, so 2 minus. And then the charge will become the subscript over here. So we have Mg2S2. Do not forget to reduce to the lowest common denominator. Therefore, it will be Mgs. Now let's check. If we have a neutral compound with an overall charge of 0, 2 plus, and then 2 minus. Now, same thing for strontium and bromine. Strontium group 2, so Sr, 2 plus, loses. Bromine, halogen, nonmetal, gains 1 electron. Let's do the crisscross method, and then we have here SrBr2. Now let's check. For every 2 plus, we have 1 times or 2 times 1 minus. So we have here an overall charge of 0. Again, potassium sulfide. Potassium is in group 1, loses 1 electron. Sulfide, as we did in the previous example, nonmetal, gains 2 electrons. Crisscross method. My apologies, my pen is lagging. And we have here K2S. Now I want you to pause your video and work on these problems together to see if you really get the concept or not. Again, aluminum, Al, 3 plus, group 13, loses 3 electrons, and then sulfur, anion, crisscross method, and then we get here Al2S3. Sodium and oxygen, Na plus, O2 minus, crisscross, we have here Na2